Okay, here we have the crane's telescopic boom rotates. It's an angular velocity and angular acceleration. So this is rotating like this. At the same instant, the boom is extending with the speed. So this is going out. So really it's going like this. So, and that's going at a speed of 0.5 feet per second. Determine the magnitudes and velocities of the acceleration of point B at this instant. So we're going to start off the equation from page 379 in the textbook. That is VB equals VA plus omega cross R B with respect A with respect to B plus V B with respect to A and the X, Y, Z. Alright, so I've got that equation from here. Now let's see if we can figure out what these things are. So VB, velocity of B measured in the XYZ reference. And the XYZ reference is the stationary reference. So in our problem here, the stationary reference is the observer on the ground. So that's the velocity of this VB with respect to someone standing down there on the ground. So VA is the velocity of the origin of the XYZ. So this is going to be our XYZ frame here, and we're going to have it rotate with the boom. So there's our X, there's our Y. So it'll rotate with the boom, and there's the origin of that. Now the origin of that is not moving. It's going to be rotating, but it is not translating. So VA then is equal to 0. The next we want to find out what omega is. Omega is the angular velocity of the moving frame with respect to the ground. So that is going to be right there. So omega is 0.02 radians per second. And the next we want to know is RB with respect to A. So this distance here, since we've rotated that reference frame, is going to be 60 feet. So RB with respect to A is equal to 60 feet in the J direction. So VB with respect to A is the velocity of B with respect to A measured as an observer attached to the rotating frame. So some guy standing right here is looking out, he's rotating, and he's watching that move out. So that is just the velocity of the boom. So it's 0.5 feet per second, and that is also going to be straight out in the J direction because it's rotating with him. But he's not seeing these rotating. He's not sensing that. He's just seeing the boom move out. Okay, because he's standing right there. So then that's it. So we can solve this equation. So VB equals 0 plus omega. Now omega is going to be, it's rotating this way, so it's going to be the negative K direction. So put negative and put a K there. So negative 0.02 in the K crossed with R. Hope that shouldn't have been a big R, should have been a little R. Crossed with 60 in the J plus 0.5 feet per in the J. So if we do K cross J, I, J, K, I, J, and this is negative 0.02, and then 60 and 60. This is the only thing. So negative and a negative in the I direction, so it's a positive. So we got 0.02 times 60 in the I direction plus 60 in the J plus 0.5. Oh, sorry, not plus 60 in the J. That crossed. Plus 0.5 in the J. And so VB is equal to 1.2 in the I plus 0.5 in the J. If we're to find the magnitude, then VB is the square root of 1.2 squared plus 0.5 squared, which is equal to 1.3 feet per second. Okay, now let's find acceleration. So finding the equation on page 380, we have AB equals AA plus omega dot cross R B with respect to A plus omega cross omega cross RB with respect to A plus 2 omega cross VB with respect to A in the XYZ plus A B with respect to A in the XYZ. Okay, so we already know some of the things from up there, but let's look at what AB is defined as the acceleration of B measured in the XYZ reference. So that's what we're trying to find out, the acceleration of point B with someone on the ground. Okay, so A is the acceleration, the origin of A, and the origin of A is not accelerating translationally. It is, the rotation is accelerating, but this is the translation. So this one is 0. Okay, and then omega dot is the angular acceleration of the XYZ reference, little xyz, measured from the capital XYZ, someone on the ground. So is this the rotation of this reference here? And that is going to be 0.01. And that is going to be in the negative k direction. Okay, position RBA, we already know, 60 in the J. And what else don't we know? Velocity BA, we know that one, 0.5. And ABA, which is the acceleration of B observed with respect to the XYZ, the lowercase XYZ. So the acceleration of B observed from here, and the speed was constant. Therefore, that is 0. So B with respect to A is equal to 0. So AB is equal to 0 plus alpha dot 0.01 negative in the K crossed with RBA, which is up here, 60 in the J, plus omega, which is up there, negative 2.02 in the K, crossed with omega, negative 0.02 in the K, crossed with RBA, which is 60 in the J, plus 2 omega, negative 0.02 in the K, crossed with VBA 0.5 in the J, and then plus 0. So doing the cross products and summing everything up, and we get 0.62 in the I minus 0.24 in the J feet per second, and the second squared, and the magnitude would be the square root of 0.62 squared plus 0.24 squared, and that is 0.62 feet per second squared.